And then before we get to it, we are going to be reviewing today, by the way. So we have a lot of review problems ahead of us. But before we get into that, I also want to go over one more thing that comes up sometimes on, these tests and quizzes and stuff. So let me just go over that really quickly. Which is, do you guys remember, I hope you do, in the previous topic, how we were saying like a rational number plus a rational number is a rational number. A rational number plus an irrational number is sometimes is never rational, and then two irrational numbers is sometimes. Y'all remember that whole thing? I'm sure you have memories of that. Whether you still have it memorized is another issue, but we'll get to that. Well, there's a very easy rule for polynomials. So ready? Very easy, very, very easy. A polynomial times a polynomial is a polynomial. Simple. When you multiply two polynomials, you get a polynomial. When you add two polynomials, most of the time you will also have a polynomial, but sometimes you won't. So this is sometimes. And I'll just do a quick example of that. If I was going to add these two polynomials together, we're going to combine like terms. So when I combine like terms, what are two like terms that I can combine?
3x over to the power of 2 and negative 3x to the power of 2.
3x to the power of 2 and negative 3x to the power of 2. Well, what do I get? Positive 3x and negative 3x to the power of 2.
0.
I get 0. So when I combine these two, I get 0. What's another pair of like terms?
Positive 2x and negative 2x.
Positive 2 and negative 2, what do I get?
0.
Also 0. And then finally, I have 4 and I have 6. What do I get here?
10.
10. So I get 0 and 0 and then 10, making my final answer 10. Is 10 a polynomial?
No.
It's not. So when I say sometimes polynomial, that's because sometimes if you try to add two polynomials, this could happen where they cancel each other out and you end up with 0 and 0, and then maybe you'll have just one number left. So you've got to be a little bit careful with addition. But with multiplication, no matter what, with multiplication, you will always end up with a polynomial. And we'll kind of talk about that throughout today's class. So does anyone have any questions on these two rules? And let me write this down. Hold on. You end up with 10, which is not a polynomial. So, quick overview of everything we just covered. Polynomials have to have positive whole number exponents. So there's no negative exponents, no decimal exponents, no fractional exponents, and the variables can't go into the denominator. So only whole number positive exponents. When you multiply two polynomials, you always get a polynomial. When you add two polynomials, you sometimes get a polynomial. 99% of the time, you will get a polynomial. But every so often, they might cancel each other out, and then you don't get a polynomial. So you just always have to check. Any questions on everything we kind of covered in this little intro? All right. So now let's get to it. We're going to do some review. Starting with a little bit of addition, subtraction, but also what are we doing in this problem?
Distributing.
We're going to have to distribute. So I'm going to go ahead and let's do this one together. I'll clear up any questions that anybody still has, and then you guys will do one on your own. So if I'm going to distribute and I'm going to be multiplying when I distribute, let's do a quick review of how we multiply these numbers. So negative 3x times x, what do I get?
Negative
3x.
Negative 3x to the power of 2. And I get that because each of these x's has an invisible 1, and I'm going to be adding those two 1s together. So 1 plus 1, I get 2. All right, next one, negative 3x times negative 4. What do I get?
Negative 12x.
positive 12x.
Ooh, is it negative or
Yeah,
is it
positive. It's positive.
It's positive. Why is it positive?
Because a negative times a negative equals a positive.
A negative times a negative, I get a positive. So it's positive 12. So just make sure, just always be thinking about those little tiny rules when you're multiplying. Okay, next up. Now on the other hand, I have negative 2x times
Squared.
x.
You forgot the x for the 12.
Oh, thank you. Yeah, don't be forgetting your x's. Negative 2x times x.
Squared.
So negative 2x squared, because again, invisible 1, I get 2. And then finally, negative 2x times positive 3.
Negative 6x.
Okay, so a negative times a positive, what do I get?
No, a negative.
A negative.
You do get a negative. I'm just testing you, Lauren. Negative, okay? So again, let's just quickly. A positive times a positive. Positive number times a positive number is a
Positive.
positive. Positive number times a negative number is a
Negative.
negative. Negative number times a negative number,
Positive.
positive. So just always got to be remembering those little rules. Okay, now I combine like terms. So where do I see like terms?
Negative 3x and negative 2x.
Negative 3x squared, negative 2x squared. What is negative 3 minus 2? Or what do I get when I combine a negative 3 and a negative 2?
Negative 5.
Negative 5, good. X squared. And then on the other hand, I have positive 12 and negative 6. So in other words, I have 12 minus 6. What do I get?
6.
I get 6, positive 6. So answer choice D. All right, so this one was not too bad at all compared to what we've done already, but how do we feel? I wanted to do a kind of more basic problem so that we can really make sure we understand the basics. Do I have any questions on this problem? Look through it carefully, make sure that you understand each and every part of it. Okay, cool. So on the next slide, I'm gonna have you guys try it on your own. Okay, hold on. Somebody just asked, do you add the exponents? So in which part do you mean? At the end, when I combine like terms? Okay, so combining like terms, I always want you guys to think of combining like terms like, how do I, okay. Like, okay, here's a thing I do all the time. I like borderline probably have a little bit of OCD because when I open a bag of candy or like Skittles, I like Skittles a lot and they're all different colors. I like to organize them by color. So I put all the red ones over here, all the green ones over here, all the yellow ones over here, all the purple ones over there. I'm not changing their color, right? They don't change colors. I'm just collecting them and putting them all in the same place. So when you combine like terms, you're not changing the variable. X squared is going to stay x squared. X to the power of 1, which this is what this is x to the power of 1, is going to stay x to the power of 1. We're not changing what it is. Because if you add those variables, you change what that number is. It ends up completely changing the value of that number. So I'm not going to be adding the exponents because all I'm doing is I'm putting all of my green ones over here, all of my yellow ones over there. So if I have -3 green ones over here and I have -2 green ones over there, in total, I have -5 green ones. Okay, so that's something that a lot of students struggle with. I really want to make sure that that is understood completely. The only time that you add the exponents is if you're multiplying. So like in the first step when we were multiplying, that's when you would add the exponents. But in the second step, I'm just combining like terms, so I will not be touching those exponents at all. All right, does anyone have any other questions about that? Okay, cool. All right, so go ahead and try this one on your own. There is a little bit of a tricky part maybe to it, but I want you guys to try and figure it out on your own. Look carefully. All right, I have about half of the students have answered, so I'm going to give it another 30 seconds. All right, 5, 4, 3, 2, and 1. Here's the results. So 73%, that's pretty good. 73% got it right. That's awesome. I want to keep aiming as the class goes on to go higher and higher and higher. So right now we're starting off the day with 73%. Let's bring that up as we go. Now let's go through it. What was the maybe slightly tricky thing about this problem?
Oh, I didn't see the X at the end.
Oh, that's what it is.
But I did choose C though. I just guessed C.
Okay, so let's see why C is correct. So the X over here, you might have missed it. That's still being distributed. They just put it at the end rather than in front. But it's still distribution because I still have parentheses and I'm still going to have to distribute into the parentheses. It's just that you got to do it kind of backwards. So we're going this way, which they do sometimes. So it just, it kind of, you got to see it as don't ignore it. But remember that sometimes they might put it there instead because they love to do those little tricks. So going ahead and we're gonna we're gonna go ahead and distribute -3 times x. I get -3x. -3 times +2, what do I get?
-6.
-6. Now we're going backwards, but that's okay. X times x.
X squared.
And x times -3.
-3x.
There we go. So now I can combine like terms. -3x and -3x make what?
-6x.
-6x minus 6 plus x squared. And what's wrong with this?
It's not in standard form.
It's not in standard form. We got to put it in standard form. What goes first when you write it into standard form?
X squared.
Then what?
-6x.
Then finally,
-6.
-6. So answer choice C. A big common mistake that a lot of students make. What's x times x?
X squared.
Why?
Because if you hold on, I have to.
It's okay.
Is it because x squared is the same thing as x times x because of the one exponent they have in front of each other?
Yeah, when you add the exponents, you get 2. That's different than 2 times x. 2 times x is 2x. But when you multiply a number times itself, multiplying any number times itself, you get an exponent of 2. So that's a common mistake. So just make sure. Does anyone have any questions on that? Okay. All right, so this is the answer for this question. Does anyone have any questions on it? Awesome. All right, here's another. So let's see what's different here. They gave us the final answer. You have to figure out which of these answer choices will give you that answer. So it's a little bit longer because now you got to distribute until you find the right response. See if you can figure it out for yourself. And let's see if we can get better than 73% correct. I think we can. Go ahead and take about 2 minutes. All right, half students have voted. I'll give it 30 more seconds. Right now we're doing better than 73%, but not by much. We're at 75%. So let's see if we can bring that up. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Nice job. 78%. See, we're already doing way better. That's awesome. Okay, so 78% got it right, but of course, I have a couple students who did not, so let's go through it. I'm going to go from bottom up. I'm going to go from the bottom to the top, just so we can see why everything else is wrong, because it is A. So let's go through it. When you distribute, just be very careful. Make sure we're looking at positives and negatives. We get -3 times y to the power of 3. I have -3 y to the power of 3. -3 times -2y. A negative times a negative is a positive, so I end up with positive 6y squared. So already we know that this is wrong. Okay, because we needed it to be a negative, but it ended up being a positive. So already this is wrong, just based on the sign. But let me just finish it. -3 times -2 is positive 6. And I needed that to be a positive 6y. So it does not match. It does not match. Next one up. Okay, when I distribute, I end up with -3y to the power of 3. So far so good. Then I get -6y to the power of what?
-y to the power of,
So on the second distribution, what is the exponent that I get?
3.
3. But what should I have?
2.
You wanted it to be a 2, so it doesn't work out. And then even on the third distribution, -y times -2 is positive 2y. So again, it doesn't match. And then B, same thing. I get -3y to the power of 3. So far, so good. Then I have a negative times a negative, so I end up with positive 6y squared. So already it's wrong. But if I do the last one, -y times positive 2, I get -2y, which does not match. So answer choice A was the correct response. Let's go ahead and just do that one, just so we can show why it's right. I get -3y to the power of 3 minus 6y to the power of 2 plus 6y. So that one matches. So answer choice A was correct. Do I have questions on this one? So if you started with A and then you were going to go down, if you started with A, you probably saw the correct answer right away, which probably saved you a little bit of work. But it's always good to check every response just to make sure, because you never know, you might have made a mistake. You just want to be sure. Questions on this one? All right, let's try another. Okay, now I'm multiplying a binomial times a binomial. So what is one strategy I can use?
A squared something.
FOIL, yeah. So I can use FOIL. What's another way to do it that we learned yesterday?
No. A plus
A squared, I think.
Okay, so
A plus B.
okay, so what you guys are giving me is the perfect square trinomial. But that only works if you have a perfect square trinomial. This is not a perfect square trinomial because remember, that only works if I have something like that, where you're squaring a binomial. So don't get them mixed up. That only works in this kind of scenario. So in my example, I'm not going to use that. I can use FOIL. And then there's one other way though. Does anyone remember from yesterday?
Oh, 2x 2x parentheses, 2x squared parentheses x minus 2 parentheses plus 6 parentheses x minus 2 parentheses.
Right, so that's called partial distribution. So I start with the first term and I distribute that. Then I go to the second term and I distribute that. So that's one way to do it, or you can use FOIL. So either way, you will get the same response. Let's see if we can do it on your own. Go ahead and try it. Go ahead. So 78% on the last question. Let's see what we get this time. Looking good. Looking good so far. I'm still missing half of the students, so go ahead, 30 more seconds. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, we were on a good roll. We had like 80%, and in the last few seconds, it kind of went down to 70, but that's still pretty good. Still pretty good. I'm not mad. Let's go through it and see what happened here. So answer choice D is the correct answer. So well done to those who chose answer choice D. That is correct. Now, no matter which way you do it, you should come up with the same answer. So I'm going to do it both ways. I'm going to start with partial distribution, and then I'll do FOIL, okay? So first thing, partial distribution. 2x squared times x, I get 2x to the power of 3. 2x squared times negative 2, I get negative 4x squared. 6 times x, I get 6x. 6 times negative 2, I get negative 12. Then, are there any like terms? Can I combine anything?
No.
Nope, there's no like terms. There's nothing else that I can do. That's it. That's my answer. So it's answer choice D. Now, if I do FOIL instead, I am going to get the same exact answer, just a slightly different way. So let me bring this down. Oh, okay. It quit on me. It happens sometimes. Okay, so let's go ahead and check it out with FOIL. With FOIL, first times first, I'm doing 2x squared times x. So I get 2x to the power of 3. Outside terms, 2x squared and negative 2. That's negative 4x squared. Inside terms, positive 6 and x. That's positive 6x. And last, 6 times negative 2 is negative 12. So D, again, is the correct response. If you chose B, that means you are not foiling correctly. If you chose A or B, then you didn't foil all the way. You skipped the middle part. And that middle part is extremely important. We can't ignore it. So take a look, make sure that you understand how to do it properly, and let me know if you have any questions on this one. So, okay, so I'm seeing some people are telling me what they did wrong. And somebody said that all they did, so here's the original problem, that they just did this times this, that's 3x cubed, 2x cubed. And then they just did 6 times negative 2 is negative 12. But that's not FOIL, right? That's not FOIL, because FOIL means you have to do every single combination. So if that's all you did, you skipped half of the combinations. So again, FOIL, you have to make sure you're doing it properly, making sure that you're hitting each and every combination. And if you got a different answer, if you did FOIL and you got a different answer, then take a look again and make sure you understand where I got my numbers from. If you're not sure how I got any of the numbers you see, ask now. Now's the time. So if you made a mistake and you're not sure what you did wrong, now's the chance to ask. All right, going once, going twice. Okay. Okay, and then finally, so we've done FOIL, which is a binomial times a binomial, but what do I have here?
A binomial times a trinomial?
Yeah. Binomial times a trinomial. So what do I do in this scenario?
Do what we did for when you told us like what other step we could do for FOIL. Just break it down, distribute. So
Good.
x parentheses, x parentheses x squared minus 3x plus 7 parentheses plus 1.
Good. And then again, parentheses, x squared minus 3x plus 7. So we're just splitting it up. This is called partial distribution, because you're splitting up the binomial and then distributing each part of it individually. So we split it up. Now I go ahead and I can distribute. And the most important part when you do this is just to make sure that you're keeping things nice and neat and that you're not rushing or trying to do things in your head. So we're going to go ahead and do it together. Let's go ahead and do this together. So starting on the left side, x times x squared, what do I get?
Sorry, I lost connection.
That's okay. So the first one over here, x times x squared, what do I get?
X cubed.
X cubed, x to the power of 3. Next one, x times negative 3x.
X times negative 3x, negative x squared. I mean, negative 3x squared.
Negative 3x squared. Again, 1 plus 1 gives me 2. Next one, x times 7.
X times 7 equals 7, positive 7x.
Positive 7x. Beautiful. Next one, now I'm just multiplying everything times 1. So anything times 1 is just going to stay the same. I don't really have to change anything from here. So it's just plus 1x squared minus 3x plus 7. Now we combine like terms. Can I have somebody who I haven't heard from in a little bit give me 2 like terms, one pair of like terms?
Negative 3x to the power of 2 and 1x to the power of 2.
Good. All right. Another pair of like terms?
7x.
7x and negative 3x.
7x, negative 3x. And now I combine everything. So what do I write down first?
X cubed.
X cubed. Next.
X squared.
X squared. So here I have negative 3 plus 1. What do I get?
Negative 2.
Negative 2. Oh, I'm sorry. This is a 3, not a 2. My bad. Okay. Then I have a 7 and a negative 3. What's 7 minus 3? I'm just
4.
Just 4x plus 4x. And then finally, plus 7. So altogether, that is my final answer. And remember, when you combine like terms, you're just bringing things together. You're not changing the exponent at all. So how do we feel about this? Do I have questions on this problem? Somebody was asking me, why did I put a plus on the 1x right here? Why did I put a plus sign there? Right over here. Can anyone answer that question? Why is this a plus and not something else?
Because the 1 was a positive instead of a negative.
Yeah, because this was a positive 1. So when I multiplied it, I have to put a plus sign there because I have to show that I'm adding, right? You have to show that from the 7x from here, now I'm adding 1x. Or I could have written this as just plus x. I didn't have to put a 1, but I put it there just because sometimes it's easier to understand it. Like when you're combining like terms, I put a 1 there just so that I know that I'm adding 1. You know, I'm doing negative 3 plus 1. So that's why I put a 1, just as a placeholder. But in my final answer, I didn't put a 1. Any other questions? Okay. All right. Here's an interesting one. What is the perimeter of a triangle whose side lengths are x squared plus 4, 2x minus 1, and 5x? What's perimeter again?
Adding.
We add. So if I draw this out, what this means is that the side lengths, doesn't matter which one's which, but I have x squared plus 4, I have 2x minus 1, and I have 5x. And if I'm looking for the perimeter, well, that just means I need to add up all three sides. So I'm adding. So the perimeter would be x squared plus 4 plus 2x minus 1 plus 5x. Go ahead and try this one out on your own, and let's see if we come up with the same answer. What operation am I doing again, you guys? What's the operation?
Adding.
Adding. Since there's pluses in between, I'm adding those numbers. I am not multiplying anywhere. So we're adding everything, yep.
And we send the answer to you.
Yeah, you can send it in the chat. I'll give everyone 30 more seconds. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, so I'm seeing two different responses. Some people are giving me a trinomial as the answer, and some people are giving me a binomial as the answer. So the answer should be a trinomial. Look carefully. What are my like terms?
2x and 5x.
2x and 5x. That's one pair of like terms. What's the other pair of like terms?
1 and 4.
Negative 1 and 4. So when you're adding things like polynomials like this, you can basically get rid of the parentheses. So the reason I had the parentheses to begin with was just to separate, to say, okay, this is one binomial, this is another binomial, and this is a monomial. But since I'm adding them together, those parentheses don't really need to be there. You only really need those parentheses if you're multiplying or subtracting, which we'll talk about. But in this case, I'm adding, so I can basically get rid of all those parentheses and just combine like terms. So like Lauren said, I have 2x and 5x, and then I've got a 4 and a negative 1. So in total, I have x squared plus 7x plus 3. Okay, so be very careful because I saw a few people, what they did is they combined like terms and they included the x squared. But the x squared is its own thing. It doesn't have any like terms. So it can't be combined with anything else. All right, any questions on this one? So perimeter means that we're adding, but what's the scenario where you would multiply?
Area.
Area. So if it was asking for the area, you would have to multiply. But that would be area of a rectangle, by the way, not a triangle. Okay. Let's try another. So this one's a little bit more complicated, but can I have a volunteer read, please? Who can read?
I'll read.
Okay, pause. I just want to go back because someone requested that they could, if I could go back for a second so that they can take a picture. Go ahead real quick. Okay. All right, now go ahead, Ajara.
In the diagram at the right, the dimensions of the large rectangle are 3x minus 1 by 3x plus 7 units. The dimensions of the cutout rectangle are x by 2x plus 5 units. Which choice expresses the area of the shaded region in square units?
Okay, so this is a little tricky, but let's talk about it. So this inside portion is the cutout. So what that means is that they started with like this whole big rectangle, and then they took this green part out. Okay, they took it out. So we were left with this like shaded, it looks like bricks. Okay, so it's like you start with everything, but then you take this part out. And we want to figure out what's the area of everything that's left over. So if I'm trying to find the area of everything that's left over, what I want to start with is the whole thing. So I want to start with the area of the whole thing. So let me write that down. Area of the whole thing. And since I'm taking this portion out of it, what should I do with those numbers?
Subtract that portion.
Subtract that portion. So I'm going to do area of the whole thing minus area of the cutout. Right? Since I'm taking it out, that's what I got to do. I got to subtract it because I'm taking it out. So area of the whole thing. Remember what I just said. Area means what operation?
Multiplication.
Multiplication. So in order to get the area of the whole thing, I'm going to multiply the length times the width. So the area of the whole thing would be 3x minus 1 times 3x plus 7. And what would be the area of the cutout?
2x plus 5.
Just 2x plus 5?
No. Times x.
Times x. Good. So 2x plus 5 times x. All right, so that's what I'm doing. So I find the area of the whole thing, and I'm going to take away the area of the cutout. So start working on it on your own. I'm going to give everyone about 2 minutes to just start on it, see how far you can get. Maybe you'll get the whole answer, but we'll finish it off together. If you have an answer, send it to me in the chat, but if not, there's still 30 seconds remaining. All right, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. All right, let's take a look. Check it out. Because I'm seeing a couple of different types of answers. A good amount of you guys are correct, by the way. But there's a little bit of misconceptions. So I have two binomials, the pink ones. So what do I have to do first?
Foil.
We FOIL first, we multiply first. So I'm going to be FOILing over here. 3x times 3x, I get 9x squared.
Oh,
So you get 6 by accident?
yes.
3 times 3 is 9, y'all. 3 times 3 is 9. That happens to me all the time. 3x times 7. 3 times 7, I get 21x. Negative 1 times 3, I get negative 3x. And negative 1 times 7, I get negative 7. So here's my first polynomial. Now I'm going to go ahead and I'm going to multiply the second one. Now in this case, I'm not really foiling. What am I doing on the green ones?
Distributing.
Yeah, just distributing. Notice how it's this thing again where it's going backwards. I still have my minus sign. That's not going anywhere. And now I have 2x times x. I get 2x squared. And then 5 times x, I get 5x. All right. Now, at this point, I'm going to subtract. But here's where we got to remember, because we haven't reviewed it in a little bit, what happens when you subtract?
You gotta change the signs.
Got to change all the signs. So that negative symbol, don't forget, you have to distribute it as well. And what's going to happen is all the positives turn negative and all the negatives turn positive. And that's something that is really, really important. The other thing I'm going to do is just combine like terms over here. So here I have 9x squared. What's 21 minus 3?
19.
Not 19.
19.
18. 18.
18. So 18x minus 7. And now I switch all the signs. So I have minus 2x squared minus 5x. And now finally I can combine like terms. So I have 9x squared minus 2x squared. What does that get me?
7.
7x squared. 18x and minus 5x. What do I get?
13x.
13x. And then negative 7 is left over. Answer choice D. If you got answer choice C, if you got C, that means you forgot to distribute the negative. That means you had plus 5x rather than minus 5x. But don't forget that when you subtract, you have to switch the signs of the things you're subtracting. That's what subtraction means in reality. When you subtract, you take away. So you got to flip all the signs. So congrats if you got it right. A few people, I'm very, very, very happy to see that they got it right. But if you didn't get it right or you were struggling through it, take a moment, see if you have any questions. And by the way, this is like the most challenging problem you're going to get. You know, if you already feel good about multiplying binomials using FOIL, if you feel good about combining like terms, if you feel good about subtracting with like terms, then great, that's the majority of the test. But you also have to be prepared for maybe 1 or 2 problems that make it a little bit more challenging by turning it into something like this, you know, where you have to kind of like use those skills for something new and something different. Any questions on this one? All right. So I have one more that's challenging, but then we also have our Friday quiz. And I want to make sure that everybody has a fair amount of time for the Friday quiz. So what I'm thinking is we'll do this one on Monday as a bell ringer. But on the quiz, it's not going to be this challenging. I'll already tell you that. It's not going to be this challenging on the quiz. So don't stress out that we're not doing this problem because you're not going to really need it to be able to do the quiz. Okay? So at this time, it is quiz time, Friday quiz. If you forgot that Fridays are quiz days, then I'm sorry. This is kind of a pop quiz for you. But for the most part, I try to get these quizzes for Fridays. The quiz is on everything that we just reviewed. So adding, subtracting, and multiplying polynomials. So if you feel good about those things, then hopefully you feel good about the quiz. I'm about to put it on Teams. It'll be under period 1. You have the whole remaining time to work on it. And if you don't finish during class, it is due at midnight tonight. Now, what else is due at midnight tonight?
Homework.
Khan Academy.
The Khan Academy. So remember when I said get it done ahead of time? That's because there's also this now. So if you left it for the last minute, then I'm sorry, but you got a lot of work to get done tonight. All right. Okay, I just assigned it. It should pop up in the next couple seconds. Go ahead and get onto Teams. You guys have 15 minutes to work on it now, and if you don't finish, it'll be due at midnight tonight. It's still loading, so if you don't see it yet, I'll let you know when it comes up. Okay, it should be up now. So go ahead and get started.